Quick lesson for you today on one theorem. However, it's a fairly important theorem. And we'll get to that in a second after Natalie enlightens us with an earth-shatteringly good joke, which she has been keeping to herself for days and days until we record. But now that we're recording, she's going to share with us. Is it a clean joke?
Yes, it is.
All right, go ahead.
Okay. Why couldn't the pirate remember the alphabet?
I don't know. Why couldn't the pirate remember the alphabet?
He always got lost at sea.
Oh, I just snorted. I thought you were going with the R.
Yeah.
Right? Y'all thought that, right? I was trying to figure out how she was going to work that in, but they always get lost at sea. That's a good one. Good pirate joke, yeah. We should have saved that for Talk Like a Pirate Day.
Yeah, that day?
Yeah, what day is somebody ask the Google, what day is Talk Like a Pirate Day? Nathan, you on that?
Yeah.
Out of what?
Ask
The Google knows all.
my brother will be doing homework and I can just say from across the room like, okay Google, and it'll like pop up the Google thing on the screen. It's so weird. It's
September the 9th. Oh, we've missed our opportunity to share Talk Like a Pirate Day together.
Oh, we could all fill
Could
the
we make
course
our
and
own?
then take it next year with you.
You want to make your own day? Well, we can't use, what would you like to talk like? What do you think about it?
Talk like
I'm all for it. We
Like
can,
a-
we can create our own.
Like a southern.
I'm sorry?
Like a parrot that's like on the pirate's shoulder. So it's not exactly like talking like a pirate, but it's like the parrot's already talking like a pirate.
That's a good idea.
What? You know what I mean? Because like the parrot's copy.
So we'd have to start everything with rah.
No. We wouldn't. It would just be. It would be like talk like a pirate day. It was disguised in like we're going through the parrot. If you know what I mean.
Caitlin's uncomfortable when you keep repeating parrot. That's her last name.
Oh yeah.
So we don't want to get confused with talking like Caitlin versus talking like the bird.
Yeah.
Okay. So you're saying we would just talk like a pirate, but that pirate would be the bird impersonating the pirate whose shoulder he's sitting on.
Exactly. So you can still just talk like a pirate, but we can make it today.
So you found a loophole.
Yeah.
Interesting. Let's get started with this guy. Quick review, you know this already. There's that scale factor which allows you to set up all the proportions and solve for the things. And then the second one is the more important one. Anything you can measure with a ruler has that same ratio. So whether it's the sides of the figure or the altitudes, angle bisectors, medians, perimeters, again, anything you can measure with a ruler. What doesn't work is area and volume. So that having been said, we have this little guy. Go ahead and solve that one as a little warm-up. Don't be bashful about firing up those calculators. Natalie, since you started us off with a joke, what'd you get for x?
7.5.
How do we feel about 7.5?
Yeah.
Yeah? Okay, what proportion did you set up, Natalie?
I did 5 over x is equal to 8 over 12.
Beautiful. Cross multiply. 8x equals 60, so x is equal to 7.5. We're all okay with that? You may have set up your proportion a little bit differently. You may have done x over 5 equals 8 over 12. You could have done x over 12 equals 5 over 8. Any combination that's valid, but when you cross multiply, you should get 7.5. Any issue? Okay, Natalie, back to you. What's special about the point M and the point T?
They're midpoints.
Good. So what's special about the segments MK, mongoose, kangaroo, and turtle, raccoon?
Are they altitudes?
Are they altitudes?
No,
No.
they are medians.
They are medians?
I think so.
You think so? Is she right?
Yeah.
Yeah, they're medians. Good, because they connect the vertex to the midpoint of the opposite side. Well done. Let's move on. So that's a quick review. Let's get into a new theorem here. And I can't work my own board. There we go. Okay, angle bisector theorem. There is a common misconception, look up here first, it's a visual, that if the angle is bisected, it bisects the opposite side. That, however, is not true. In this big fancy geometric blah blah blah, it explains that it actually splits it proportionally. This top black paragraph is not the most helpful. What's more helpful is what's in red. Now the chunks are the pieces of the opposite side that are split in half. So left chunk over left side would be A over B, so the left chunk of the opposite side over the side next to the angle is equal to the right chunk, which is C, over the right side, which is D. The only time that angle bisector will split the other side equally is when it's an isosceles triangle. And we don't want to assume that any triangle is isosceles unless we have other information. Left chunk over left side equals right chunk over right side. So that the proportion cross multiplies, so. I got 2 examples for you, then we're done. Okay, we good? Nope, not yet. How about now? No? Okay. How about now? Yeah, good?
No.
Yeah, no? Okay. Wait, no. Okay. How's that? Okay. Smart I am, that didn't record. Can't prove that in a court of law. Because you guys will all testify in my favor, right?
Oh, Mr.
It's not funny, Leo, how people lose their job. They'll make me come back there and hit you. Solve for x. Notice this is different than, I'm going to talk while you're solving. This is different than the original example we did. The original example was comparing 2 triangles. This one we only have 1 triangle. Do you have a question, Leo, or are you just waving your hands in the air like you just don't care?
Answer.
You have an answer? Hold on. Big E tonight? What do you got? What? No, not me, sorry. What team are you playing? And what are you doing? What's the second one? Oh, beam. That said peeps. Like, what up, peeps? And the girls are uneven. Guys are parallel bars. Well, of course, your bars are parallel also because you're an excellent geometry student, so you know that. So why are the guys called parallel bars and yours are called uneven? Yeah, but they're still parallel, right?
Yeah, they are.
Parallel, they're just like guys are like this, but girls are like,
Yeah.
but they're still parallel.
It's on a different plane.
But most of the non-bright geometry people wouldn't see that as parallel. So you should bring that up at the meeting, go ask the officials. Hey, before I get on this, you realize those are parallel. See how that would go over in conference? You're not gonna do it right. What do we get for x? Faith?
10?
10?
Yeah.
How do we feel about 10?
Good.
Good, all right. What do you got, Faith?
Since it's left chunk over left side, it's 15 over x. And then right chunk over right side is 9 over 6. And then cross multiply.
90 equals 9x, so x equals 10. Any problemas? No? Okay, beautiful. Let's ramp it up a little bit. Try that one. Looks good. I like it. For those of you that are struggling, how long is ST?
18 minus
Oh.
x.
Becca?
18 minus x.
Hot diggity. 18 minus x. That might help you. Awesome. All right, Becca, what'd you get?
X equals 5.4.
5.4?
Yeah.
Hot diggity. All right, what did you set up?
18 minus x over 14 equals x over 6.
18 times 6 would be 60 plus 48, 108. Minus 6x is equal to 14x. So 108 is equal to 20x. So x is equal to, what'd you say, 5.4?
5.4, yeah.
5.4, well done. So if x is 5.4, how long is ST?
12.6.
12.6. 18 minus the answer of 5.4. Good. Anything tough about that? Okay, you have to be sure in solving these problems that you identify it as an angle bisector first. Either it's given to you in the problem, the angles are marked, or there's something that indicates that it's an angle bisector. Don't automatically take that picture and apply the angle bisector to it, or angle bisector theorem to it. You have to establish that this segment is an angle bisector first. Then you can do left chunk over left side equals right chunk over right side. We are done. Okay, so let me stop this first.